So, we are going to be solving quadratic equations in this next unit, in Unit 6b. One thing to keep in mind at all times, if you graph a quadratic equation, which is an equation with y equals x squared, it might be 3x squared minus 4x plus 12, but it has an x squared, it doesn't have an x to the third power. It has to have an x squared. If I graph these, I get a parabola that either opens up or down. When we solve these, we are trying to find where this parabola crosses the x-axis. Keep in mind, 99% of the time, the ones we are going to give you to solve cross the x-axis in two places. Well, they might be two places that are negative. It might be like -3 and +3, or -12 and -5, but the vast majority of solutions, you're going to have two answers. So, the very first thing I'm going to ask myself as I solve any of these is, what is being squared? I have to start thinking that way to know how to solve these, because I want to isolate the thing that's being squared before I do anything else. So in this case, just the x is being squared. I want to get this x squared by itself on one side of the equation. It's already there. This actually asks me, if you remember, squaring means to multiply something by itself. So this is saying, what can I multiply by itself and get an answer of positive 81? Well, you can use the square root button on your calculator to take the square root of 81, and it's going to tell you 9 is the solution. Unfortunately, it's not going to give you the other one, and you have to keep in mind, again, the vast majority of the time you're going to find two answers. Think about it, though. A positive times a positive is a positive, so positive 9 times positive 9 is positive 81. But a negative times a negative is also a positive. So if I take -9 and multiply it by itself, which is what squaring means, I'm also going to get an answer of positive 81. You need to have both of those solutions. It's okay to put the -9 before the positive 9 in your answer. The order of that does not matter this year. What is being squared in the second one? Again, just the x. So I don't want this plus 5 out here on this side of the equation. I want to isolate the x squared. I'm going to subtract 5 from both sides of the equation first. So x squared equals, and I am so sorry, I forgot to show a required work step in here that I'm going to come back and put in. X squared equals 49 over here. The way I undo a square is with a square root. So I'm going to take the square root of x squared. And that's equal, if I take the square root of the left side of the equation, I have to square root the right side of the equation too. Oops, I wrote 9 instead of 81. Wrote where I was going instead of where I was. The notation that's also important in front of us here is I'm going to look at both the positive and the negative square root of 81, which is why I get both positive and -9 as my answers. You must have a work step between here and here. So, the way I'm going to undo this x squared is to square root it, because a square root undoes a square if that's all that's on that side of the equation. That side of the equation is going to be x. But if I square root the left side, I have to square root the right side as well. And my two answers are going to come into play because I'm going to go with both the positive and negative roots. So x equals -7 is one of my solutions, and x equals positive 7 is the other one. Again, it's okay with me if you write the positive 7 before the -7. The x is the thing that's being squared here, not the 3. So I don't want the 3 on this side of the equation. So first I'm going to divide both sides of the equation by 3 to get x squared equals 25. The way I'm going to get rid of this square is to square root. And I'm going to look at both the positive and negative square roots of 25 on the other side of the equation. So x equals -5 is one of my solutions, and x equals positive 5 is the other solution. The thing that is being squared here is not just the x. It's this entire binomial. So it's already isolated. The thing that's being squared is already by itself. I want to get rid of the square, so I'm going to square root this. X plus 3 squared, but take the square root of that, is equal to both the positive and negative square root of 4. Again, the square root symbol, if all that's on this side is squared, just undoes the square. So the left side of the equation is not x now, it's x plus 3. And it equals, square root of 4 is 2, positive 2, So x plus 3 also equals negative 2. I'm just going to solve this equation. Subtract 3 from both sides. And 2 minus 3 makes this x negative 1. Subtract 3 from both sides. Negative 2 minus 3 is negative 5. Here, the thing that is being squared is this binomial, x plus 1. So I don't want this minus 5 out of the end. I'm going to add 5 to both sides, and then I'm going to move this down here because I'm running out of room. You have a little bit more room on yours. So I've got x plus 1 quantity squared equals 121 now. I want to undo this square, so I'm going to square root both sides. Remember, this notation is important. I'm going to take both the positive and negative square root of 121. The square root undoes the square, so x plus 1 is left on the left side of each of my two equations. Oops, 1. The square root of 121 is 11, so it equals negative 11 and positive 11. When I subtract 1 from both sides here, negative 11 minus 1 is negative 12. Subtract 1 from both sides here, and 11 minus 1 makes this x 10. Again, the thing that is being squared here is this binomial, so I don't want the 4 out front, and I don't want the plus 7 at the end. Think about if this was just 4 times m plus 7 equals 151, and what you would do first. You wouldn't divide by 4 first, you'd subtract this 7 out of the end first. So that's what we're going to do here. And I get 4 times x minus 5 quantity squared equals 144. Now I don't want the 4 out front, so I'm going to divide both sides by 4 to get this thing that's being squared by itself. Then to get rid of the square root both sides. Don't forget you're looking at both the positive and negative square root of 36 on the right. So when I undo this square, what's left is x minus 5. It could equal positive 6, or the x minus 5 could equal negative 6. When I add 5 to both sides to solve these, I get x equals 11. Oops, sorry about that. Add 5 to both sides here, and x equals negative 1. If you get the thing that's being squared by itself isolated, so the thing that's being squared isolated, and it's x squared, or a binomial squared, not these other things outside. You would have to do this work first, and it equals a negative number. If you think about it, if I multiply a negative by itself, I'm going to get a positive. If I multiply a positive by itself, I'm going to get a positive. So in the number system we are currently working in, which is the real number system, you can't do this. So if I get down to this, and I'm getting ready to square root, and this side is still negative, my answer is no real solution. There is actually a solution. There are two solutions, but they come into play in advanced algebra when you get into the complex and imaginary number system. So don't write no real solution unless you're to the point where you would square root. If you're back here, where first you'd have to subtract 7 from both sides and divide by 4, do that first. Thanks, guys.